common factoring, finding the GCF, the greatest common factor. First, some skills to remember before we start to common factor. How to multiply and divide polynomials and the difference between like and unlike terms. When you're multiplying polynomials, you take the term outside the bracket and expand. Distributing the 2x to the first term becomes 6x squared y. Taking the 2x and distributing over to the negative 4x squared becomes negative 8x cubed. 2x distributed to the third term becomes positive 10x cubed y cubed. What you need to remember is that when you're multiplying exponents, you are adding them. Over to division. Deal with the numbers first. 15 divided by 3 becomes negative 5. When you're dividing, you are subtracting the exponents. So x2 minus x1 becomes x. y4 minus y2 becomes y2. And z7 minus z3 becomes z4. The difference between like and unlike terms. In the like section, you'll see that each of the variables is st squared. The coefficient can be anything, but the variable in each of these like terms is exactly the same. Over here with the unlike terms, you'll see that the 4 is st squared, but the 7 is s squared t. And those are completely different terms. St squared is different from s squared t. You might think that the 4 is like the 4st, but the 4 would also have to have the same variable following it for it to be like terms. So the three terms here are unlike. Binomial common factor, finding the GCF, the greatest common factor. To illustrate this, I'm going to break down my trinomial into its smallest pieces by prime factoring. So 8 broken down will be 2 times 2 times 2. X broken down will be x times x. This is the equivalent of 8x squared. The same thing now for my second term. This will become negative 3 times 2 times x times y times y. Positive 4 broken down is 2 times 2. The variable, the 2 x's, and the y. Now with each of our three terms broken down into its smallest pieces, let's find the greatest common factor. Looking at just the numbers, you can see that 2 is common in each one. No other number is common. There are lots of 2's on the screen, but there are no 2's left in the middle term, and there are no 3's in the outer two terms. So we have now found the greatest number that's common to each. Looking at the variables, you can see that you've got 2 x's in each. And then looking at the y's, you'll see in the first term, there isn't a y. So you have now found the greatest common variable in each of the three terms. So the greatest common factor will be 2x squared. Now every line of math must equal the one above it, so I must account for what's left. In my first term, I've got 2 times 2, which is 4. In my second term, I've got negative 3y squared. In my third term, I've got 2y. So I have now factored my trinomial. Is there a way to figure out if we've done it correctly? Well, what we have done is we've taken each of our original three terms and divided it out by 2x squared. 8x squared divided by 2x squared is 4. The second term divided by 2x squared is negative 3y squared, and the third term divided by 2x squared is 2y. We're just dividing our trinomial by our common factor. So if we're dividing to get to the third line, then if we expand, use the opposite operation, we should get back to the beginning. So 2x squared times 4 is 8x squared. 2x squared times negative 3y squared is negative 6x squared y squared. And 2x squared times my third term becomes 4x squared y. So it looks like my check equals my original. So that means I have prime factored and then found my greatest common factor successfully. If you would like to pause the video now and try the second example, I'm going to pause speaking for 3 seconds and then start again. Hopefully you're back and you were successful. I'm going to use the same technique to illustrate what the greatest common factor is in the second example. So 9 will break down to 3 times 3, s times s times t. My second term, 3 times 5 times s times t times t. My third term, negative 3 times 2 times s times t. Using the same technique, let's look at the numbers first. You can see that there's a 3 that's common to each of the terms. And you can see that you've got a t and an s that's common to each of the 3 terms. I'm going a little bit faster now. The greatest common factor will be 3st. Each line of math must equal a line above it, so I'm left with 3s, 5t, and negative 2. Again, to get this, once you've found your greatest common factor, what you're doing is taking each of the terms and dividing it by your common factor. So 9st squared divided by the common factor gives you 3s. 15st squared divided by 3st is 5t. And negative 6st divided by 3st is negative 2. I'll check it once more. The opposite operation is multiplication, so let's multiply out. This is 9s squared t. This becomes 15st squared. And this becomes negative 6st. The check equals the original, and so we have found the greatest common factor. 2 more examples. This time I'm not going to show the prime factorization. I'm going to do that work in my head. Looking at the 3 terms, I'm going to look at the numbers first and recognize that 7 is the largest number that's common to all 3. Looking at the variables, I can see that a is common to all 3, and no other variable is in all 3 terms. So 7a is my greatest common factor. Every line of math must equal the line above it, and what I'm doing is dividing the original term by the greatest common factor. So the 7's cancel out, the a's cancel out, and in my first term, I'm left with x. I'm going to do the same thing to my next 2 terms. A's cancel out, 14 divided by 7 is 2, and you're left with a y. Third term, Same thing. A's cancel out. Negative 21 divided by 7 is negative 3, and you're left with z. You have now factored out your trinomial. To check it, remember, you just divided, so the opposite operation is multiplication. 7ax, 14ay, negative 21az. The check equals the original, so you have successfully factored that trinomial. I'm going to pause my voice for 3 seconds, so if you'd like to try the second example on your own and then check your solution with me, now's your chance. Okay, the next example, you can see by the numbers that each of them will have a 2 in it. Look a little bit further and you'll see that 6 is the largest number that's common to all 3. Now looking at the variables, they're all different. These are not like terms. If you look at m, you can see that you've only got one m in the last term. It is common to all 3, so m is the greatest common variable of m to all 3 terms. Turning our attention to n, there's only one n in the first term, so it too is the greatest common n variable of all 3 terms. Each line of math must equal a line above it, so I'm going to do the same process. I'm going to divide the original by the greatest common factor. 6's cancel out, n's cancel out, and I'm left with m, because m squared divided by m is 1m. Do the same thing now for the next 2 terms. And eventually you'll just do this in your head as opposed to writing it all out. 18 divided by 6 is 3. M squared divided by m, 2 minus 1, is 1m. N cubed divided by n becomes n squared. In the last term, the m's cancel out. Negative 12 divided by 6 is negative 2. N squared divided by n is n. Check it by using the opposite operation. Distribute. So 6 m squared n plus 18 m squared n cubed, and then negative 12 m n squared. The check is the same as the original. You have successfully found the greatest common factor. I now have 4 examples of binomials that we're going to find the greatest common factor of. You'll see that I have 2 examples that are identical, and I'm going to do those 2 examples 2 different ways. So starting on the left, looking at these 2 terms, I can see that the greatest common factor would be 5, x, y. And then because each line of math must equal the line above it, I divide it out, and I'm left with x in the first term and negative 2y in the second. The example below, you might think immediately that 3 is common. Then you look a little bit further and you recognize, wait a minute, 3 and 13, there's no common factors. This is not factorable. I'm going to pause my voice for 3 seconds. I'd like you to try the second example. I'm then going to do it, and I'm going to make a mistake. I'd like you to recognize the mistake because I'm going to correct it after I do it. So I will now pause for 3 seconds. Looking at 100r squared s minus 36rs squared, I'm going to do it and make a mistake. I'm going to say that the greatest common factor is 2rs. I'm going to divide. I'm going to be left with 50r minus 18s. Now, when I look at my bracket, I'm going to recognize that I haven't common factored completely the value of my numbers because 50 and 18 also have another common number of 2. I didn't account for that the first time, but I can correct it as I go. So if I pull another 2 out as a common factor, it'll look like this, and then 50 divided by 2 is 25, and 18 divided by 2 is 9. I'm going to tidy up what's outside my bracket and get 4rs as my greatest common factor, and 25r minus 9s inside. So it's okay if you happen to miss something because you'll recognize when you see a bracket that you can factor further. You can either start again or do what I did and pull out the next value that's common, being sure to multiply it as you go. If I were to do this correctly, I would have taken out 4rs at the very beginning. So if I take out 4rs and divide my first term by 4rs, I'm left with 25r. Take my second term and divide out 4rs, I'm left with negative 9s. And you'll see that the result is now the same as my correction the first time I did it. You can multiply that out again to check it. So 4rs times 25r is 100 r squared s. Multiplying the second term, and you will get back to the beginning as long as you've done it correctly. So the check equals the original, so I have found the greatest common factor. My last two examples. Looking at my trinomial, I'm going to look at the numbers first and find the largest number that's common to all three. So I recognize that 4 is the largest number. Looking at my variables now, doing it alphabetically, I can see I have a d in each one. In my third term, I only have one d, so that's the largest d that is common to each of my three terms. And then again, in my last term, I've only got one e, so that is now the largest value of e that's common to all three. Students sometimes mistake that when they see an e squared, that's the largest common factor. But because you've only got one e on the end, e is the greatest common factor. Every line in math must equal the same as the line above it, so I'm going to divide out, and I'm left with 2DE minus 4D squared E. Here's another classic mistake that I see students making. The greatest common factor is 4DE, and it's the same as the last factor. So students will often stop then because they figure that they've already completed taking out the 4DE. But when you check it, here's what happens. 4DE times the first term gets you back to the original, and 4DE times the second term gets you back to the original. But with what I've written so far, I can't get back to my third term. So you know that 4DE divided by 4DE will be 1, because anything divided by itself is 1. So now if you put in a plus 1 as your third term, when you multiply back out, you will get back to the original. So now the check equals the original, and you have common factored. I'm going to pause my voice for 3 seconds to give you a shot at trying the last example. Okay, looking at my last example, I'm hoping that you saw that 7 is the largest number and A is the largest variable. Dividing out, you're left with 2A. You accounted for the 7A by putting a minus 1 this time because that term is negative. So negative 7A divided by 7A equals negative 1. And the last term becomes negative 3B. And again, if you multiply that back out, you'll get back to the original. Now that you've watched the video, I'm hoping that you now know how to greatest common factor. You know how to check your solution by expanding, multiplying, and spot some of the common mistakes that students make when finding the greatest common factor. Yay you, and thank you for watching.